Hey guys, this is Rahul Banerjee. In today's video, we are going to learn about the binary search. So, searching means what? Searching means we have to check an element is present in an array or not. If it is present, we will return the index number. Otherwise, we will return -1 for indicating that value not found. Okay. So here in this binary search, the first condition is there should be a sorted array. Here in this example, you can see that all the values are present in a sorted order, basically in ascending order, right? So here from this array, if I want to search an element like 65, then what should I do? I have to find the middle index for getting the middle element. Okay. So how can I get the middle index? Here I am using two pointers I and j. I is pointing to the first element and j is pointing to the last element. So now for getting the middle index, I am adding I and j and I am dividing it by 2. So the value of I is 0 and the value of j is 12, right? So the answer is 6. That means 6 is the middle index and 52 is the middle element, right? And remember that 6 is the middle index. Okay. So now if I want to search 65, as 65 is greater than 52, then 65 should be present in the right side of 52. That means 65 can be there in the right side of the middle element. Why? Because 65 is greater than 52. And if I want to search 37, then as 37 is less than 52, then I can say 37 can be present in the left side of 52. That means the left side of the middle element. Okay. So now as 65 is greater than 52, then now we are shifting to the right side. So the first index of the right side is 7 and I is pointing to the index number 7, which is basically the next index of mid, and j is pointing to the last index, that means 12. Okay. So now I can say if error of middle is less than val, that means the middle element is less than the value which one the user want to search, then I will shift to the next index of middle. Now we have to get the middle index. For getting the middle index, I am adding the value of I and j, that means 7 plus 12 by 2, and now I am getting 9. Why 9? Because here I am just taking the integer part. Okay, so 9 is the middle index and 72 is the middle element of this half. So now as I want to search 65, that means as 65 is less than 72, that means 65 should be present in the left side of 72. Okay. Now I is pointing to the same index, that means index number 7, but j will shift to the left index of mid, that means j will shift to index number 8. Okay. So now I can say else if error of mid is greater than val, then j will shift to the mid -1 index because it is the last index of the left half of middle. Now we have to find the middle element for this half. So now it is 7 because I am just taking the integer part. So 7 is also the mid index. Now we can see that now also 65 is greater than 56. That means 65 can be present in the right side of 56. Okay. That means this side. So now j is still standing on index number 8, but I will shift to the next index of mid according to this formula, right? That means I is also pointing index number 8. Now we have to find the middle index. So 8 plus 8 by 2 equals to 8. That means mid is also pointing to index number 8. Now we can see the value which is present at index number 8 is as same as the value which one the user wants to search. That means 65. That means 65 is present at index number 8, which is basically the middle index. That's why in the else part I am returning mid index. Now I can write the same code like this way. That means at first I am getting the middle index Then I am checking this condition. If it will satisfy, it will return the middle index. Otherwise, if it will satisfy, I will change to mid plus 1 index. Otherwise, j will shift to mid minus 1 index. Okay. So now the current scenario is mid is pointing to index number 8. I is also pointing to index number 8 and j is also pointing to index number 8. Now just take one scenario. If anyone wants to search 60, then as per the code it will fail. This condition will also fail because 65 is not less than 60. So we will go to the else part. That means j will shift to mid minus 1 index. That means j will shift to index number 7. So now the current scenario is j is lesser than I, right? J is lesser than I. That means the value is not present, okay? So now I can add one condition in a while loop, that is this code will only work when I is lesser than equals to j, okay? Here just remember one thing, I will be always lesser than or equal to j, okay? If I will cross j, that means the value is not present in that sorted array. At that time we will return -1 after the loop. So here in this code, you can see I have declared one variable n and I am taking the number of elements into n. Then I have declared an array error with the size of n and I am simply taking n values from the user and I am storing those values into that array. Then I have declared a variable val and I am taking the value which one user wants to search into val. Then I have called the bi search function, basically the binary search function, and I have passed three parameters. First one is the name of the array, second one the size of the array, and third one the val variable, that means the value which one user wants to search. Here in this function you can see the return type of that function is int. That means we will return an integer value. So whatever value it will return, it will store at IDEX variable, and we'll check that condition. If it will satisfy, we will print value not found. Otherwise, we will print the index number of that value. So let's complete the binary search function. So here at first I will take two pointers I and j. I is pointing to the 0th index and j is pointing to the n minus 1 index, that means the last index. Then we'll write the loop. So here if I want to search 65, it will return index number 8. 65 index number 8, okay? And if I want to search a value which is not present, like 60, it is returning value not found, okay? Now let's come to the space and time complexity part. Here in this code, for getting the index from binary search function, there is no need to take any extra space, right? So I can say the space complexity for this algorithm is big of 1, okay? And in time complexity, in the best case scenario, when I am getting the mid index for the first time, at that time if I will get the value also, that will be our best case scenario. So in that case there is no need to traverse the loop, because at first we are getting this value, the middle index, and this condition will satisfy, it will return. So the loop will run only one time. So at that time, the best case scenario, the time complexity is big of 1, okay? So now let's come to the average and worst case scenario. Average and worst case scenario means the value can be found at any index. So if there is total n number of elements, here we can see we have to divide the array into two halves, then two halves, like that manner. So at first, if the number of elements will be n, it will cut into n by 2 in the next iteration, then n by 4. We know if we'll get the index or if we'll not get the index, at last only one value will be there. That means at last n by something will be 1, right? So here we can write it like that, n by 2 to the power k equals to 1. That means we can say from n number of elements to only one element, we have to do k number of steps. That means the time complexity of this algorithm will be big O of k. But we know that we have to express our time complexity in terms of n, right? Then we know that n by 2 to the power k equals to 1. That means n equals to the power k. That means log n equals to log 2 to the power k. That means log n equals to k log 2, and the base is also 2. That means log n equals to k. That means k equals to log n. So we can say the time complexity is big O of log n for the binary search. Big O of log n. So that's enough for today. If you have any doubt, you can write it in my comment section. Bye bye. Take care.